This is finding the limiting reactant. There are two methods. In an earlier video, I explained the first. In this video, I'll describe the second. In this problem, 4.00 moles of chromium reacts with 2.00 moles of molecular sulfur, S8. How many moles of chromium-3 sulfide are produced, assuming a 100% yield? Let's recognize a few things. First, 100% yield means we are looking for the theoretical yield. And second, to find the product, we need to know the limiting reactant. Stoichiometry problems will sometimes tell the reader which reactant is in excess, but the excess reactant is not given in this problem. Exact amounts of reactant are provided: 4.00 moles of chromium and 2.00 moles of molecular sulfur. We must find the limiting reactant in this problem. In this method, I'll find the maximum product for each reactant. So I'll be doing two stoichiometry problems. The reactant that yields the smallest amount of product is the limiting reactant. Let's get started. I'll start with 4 moles of chromium and convert using the mole ratios from the balanced equation. I'll find that 2.00 moles of chromium-3 sulfide can be produced from 4 moles of chromium, assuming a 100% yield. Then I can do the same for the other reactant. I'll start with 2.00 moles of S8 and convert using the mole ratios from the balanced equation to find 5.33 moles of chromium-3 sulfide can be produced from 2.00 moles of sulfur, assuming a 100% yield. Now, let's interpret the results to find the limiting reactant. Recall, the reactant that yields the smallest amount of product is the limiting reactant. Here, chromium is limiting because it yields the smallest amount of product. This would make sulfur the excess reactant. This makes sense. As soon as 2.00 moles of product is produced, the chromium has run out and the reaction stops. And before concluding, a final word on the excess reactant sulfur. Let's find the amount of sulfur remaining after the reaction is complete. I'll convert the limiting reactant chromium to sulfur to find the amount of excess reactant that reacts. Here we see that 0.750 moles of sulfur are required to fully react with 4.00 moles of chromium. We started with 2.00 moles of sulfur. I can subtract the two to find 1.25 moles of sulfur remain after the reaction is complete and all the limiting reactant runs out. This is also called the amount of excess reactant.